Hey everyone, welcome back to the networking series. Today, we're diving into IPv6, the next generation of the internet's addressing system. IPv6 is designed to replace IPv4, which has been around since the early days of the internet. In this video, we'll explain what IPv6 is, why it's necessary, and how it differs from IPv4. By the end of the video, you'll understand the benefits of IPv6 and how it's shaping the future of networking. Let's jump in. First off, let's talk about why we need IPv6. The current addressing system IPv4 uses 32-bit addresses, which gives us about 4.3 billion unique IP addresses. While that may sound like a lot, the rapid growth of the internet and the explosion of devices like smartphones, laptops, IoT gadgets, and more means that we've essentially run out of IPv4 addresses. That's where IPv6 comes in. IPv6 uses 128-bit addresses, which provides an almost limitless number of IP addresses, about 340 undecillion to be exact. This ensures that we'll have enough IP addresses for every device that needs one, now and well into the future. Essentially, IPv6 is solving the IP address exhaustion problem that IPv4 faces. Let's take a look at the structure of an IPv6 address. Well, IPv4 addresses are written in dotted decimal format like 192.168.1.1. IPv6 addresses are written in hexadecimal and are much longer, like this. The full address can be shortened by omitting leading zeros and using double colons to represent consecutive sections of zeros. For example, the following IP address can be shortened to. One of the key benefits of IPv6 is that it allows for end-to-end connectivity without the need for network address translation or NAT. In IPv4, NAT is often used to allow multiple devices on a private network to share a single public IP address. With IPv6, every device can have its own unique global IP address, eliminating the need for NAT and simplifying the routing process. IPv6 also includes several improvements over IPv4 when it comes to efficiency and security. For example, IPv6 headers are simpler than IPv4 headers, which makes packet processing more efficient for routers. Additionally, IPsec, or Internet Protocol Security, is baked into IPv6, providing stronger encryption and authentication by default. Let's talk about IPv6 address types. There are three main types of IPv6 addresses: unicast, multicast, and anycast. A unicast address is used to identify a single device on the network. Just like in IPv4, data sent to a unicast address is delivered to a single specific device. Multicast addresses are used to send data to multiple devices at once. Unlike broadcast addresses in IPv4, IPv6 does not use broadcast. Instead, multicast is used to efficiently deliver data to multiple devices without flooding the network with unnecessary traffic. An anycast address is a unique concept introduced with IPv6. With anycast, multiple devices can share the same IP address, and data sent to an anycast address is delivered to the nearest device in terms of network topology. This is particularly useful for services like content delivery networks, or CDNs, where you want users to connect to the nearest server for faster performance. One of the biggest challenges with IPv6 adoption is dual stack deployment. Since IPv4 and IPv6 are not directly compatible, most networks today run in dual stack mode, meaning they use both IPv4 and IPv6 addresses. Devices and networks can communicate using either protocol depending on what is supported by the destination. This approach allows for a smoother transition as the world gradually moves to IPv6, taking its time. Another method used in the transition to IPv6 is tunneling, where IPv6 packets are encapsulated inside IPv4 packets to travel across IPv4 only networks. This helps IPv6 traffic move across networks that haven't yet upgraded to fully support IPv6. Let's also discuss the stateless address auto configuration, or SLAAC, feature in IPv6. SLAAC allows devices to automatically configure their own IP addresses without the need for a DHCP server. When a device connects to an IPv6 network, it can generate its own IP address using its MAC address and other network prefix provided by the router. This makes network configuration simpler and more efficient. IPv6 also includes Neighbor Discovery Protocol, or NDP, which replaces the ARP, or Address Resolution Protocol, used in IPv4. NDP handles functions like address resolution, duplicate address detection, and finding routers on the network. Although IPv6 adoption has been slow, it's steadily increasing as the world runs out of IPv4 addresses. Major ISPs, cloud providers, and content delivery networks are now fully IPv6 enabled, and the number of IPv6 enabled websites continues to grow. It's only a matter of time before IPv6 becomes the standard for internet communication. So, to recap, IPv6 is the next generation IP addressing system that solves the IPv4 address exhaustion problem by using 128-bit addresses. It eliminates the need for NAT, improves efficiency and security, and introduces new concepts like anycast addresses. While dual stack deployment and tunneling help in the transition from IPv4 to IPv6, it's clear that IPv6 is the future of IP addressing. In the next video, we'll be discussing basic network security, where we'll cover key strategies to protect your network from threats. Be sure to subscribe so you don't miss it. Thank you all for watching. Your support means very much to me. I truly do mean that. The channel is obviously nothing without you guys, so again, thank you. Please consider hitting that like button, drop me a comment, and if you haven't done so, please subscribe to the channel. See you in the next video. Take care.